Hi chemists, it's Mrs. Patel Dane here. I'm going to do some calculations for topic 8.5 acid-base titrations. My apologies if this looks slightly different than what your actual sheet looks like. So here, we're going to sketch a setup for a titration. So actually I'm going to cross this out and we're just going to focus in on some calculations. So to remind ourselves the purpose of a titration, so the purpose of titration is to pretty much find the concentration of an unknown solution. So find the concentration of an unknown solution. So let's give you an example problem to start off with. So example one, we have, let's say 25 milliliters of hydrochloric acid was titrated with, let's say 10 milliliters of a 1.0 molar sodium hydroxide solution. So the first thing we need to do is identify what our substances are. So we have the acid is hydrochloric acid, so that should be HCl. We have 25 mils of this, and we don't know its molarity. It's added to a base, and let's do it this way. And that base is sodium hydroxide, so NaOH, and it has 10.0 milliliters, and its molarity is 1.0 molar. So what we can do with this is actually start a chemical equation. So we have HCl plus NaOH, both of which are aqueous. Anytime we have an acid and a base, they're going to produce water. So I'm going to write HOH and a salt. So in this case, NaCl. So let me show you where I got these from. I have the H here and there. The OH came from the sodium hydroxide. It's there and there. And then the Na and the Cl are leftovers. So the HOH is water, that's a liquid. The NaCl is aqueous. So I like to make sure I put my knowns and my unknowns above my chemical equation. So I have 25.0 milliliters, and I don't know its molarity. I know I have 10 milliliters, and it's 1.0 molar. So to do this equation, we need to figure out overall the final concentration of the HCl. So I can use something called stoichiometry or dimensional analysis to help me cancel out some units. So I might start off with knowing that, hey, molarity is moles per liter. So this is really 1.0 moles of NaOH for every 1 liter of NaOH. And that's what I need to find over here. The moles of HCl over the moles, over the liters of NaOH. I also know that this is in terms of liters, but this is in terms of milliliters. So I have to move or get this over to liters. So divide by 1,000. When I divide by 1,000, 0.100 liters of NaOH. And this is 0.0250 liters of HCl. I am squishing that all in there. Sorry about that. Let me go ahead and separate out my equation, just so that it has some of its own little space there. So I'm going to start out with the substance that I know the most about, and that's my NaOH. So I will start also then with the substance that only has no denominator to it. So I'll have 0.0100 liters of NaOH. Get that over 1. And I need to cancel out liters of NaOH, so I need liters on the bottom. So I can use this part right here. I have 1.0 moles of NaOH for every 1 liter of NaOH. And then I can go ahead and cancel liters of NaOH. I can then look at the fact that I have moles of NaOH. I need to get moles of HCl, but I can use my chemical equation to help me. So I have an imaginary 1 here and an imaginary 1 there. So I know that for every 1 mole of NaOH, I have 1 mole of HCl. So that I can cancel out moles. Oh, whoopsies. Sorry. See, I screwed that up. Make that HCl at the top, NaOH at the bottom, and then I can cross that out. That can get crossed out. Cool. So now I'm in moles of HCl. I need to figure out the liters of HCl, but I already have that from right over here. So I can take my liters of HCl, 0.0250 liters of HCl, and I essentially need a placeholder here, so that's just going to be 1. So at the end, I have moles of HCl over liters of HCl, which is my molarity of HCl. So then I need to put this into my calculator. And let's see if I can squeeze this in here. Hopefully you can see a little bit of it. I have 0.01, and I don't need to put those extra zeros in there. I'm multiplying it by 1, multiplying by 1, multiplying by 1, so I don't need to really do anything there. Then I'm dividing by 1 times 1. So again, don't need to do anything there. Then 0.025. So this ends up being 0.40 molarity of HCl, or moles per liter of HCl. All right, and then my second example. I'll do a little squiggle. So for my second example, I'm going to say, example 2. Let's say I have 13 milliliters of a 4.0 molar sulfuric acid solution. Is titrated with, let's say, 13.0 milliliters of potassium hydroxide. Find the concentration of the potassium hydroxide. So just like before, I identified my acid and my base. I wrote their formulas, and I am going to find out the information about those. So my acid is sulfuric acid, so that is H2SO4. I know that I have 13.0 milliliters of it, and it is a 4.0 molar solution. I will find my information about my base. This is potassium hydroxide, so it's KOH. I know I have 13 milliliters of that, but I don't know its concentration. So the next step I want to do is figure out its balanced chemical equation. So I've got H2SO4, that's aqueous, plus KOH, aqueous. I know I have an H, actually 2 H's in this case, and an OH, but water only comes as HOH, so I got to figure out that later on. And then my leftovers. So I have a K, and then I have an SO4. That SO4 is going to be a -2 charge. K is a +1 charge. So I need to have twice as many Ks as I do SO4s in order for this compound to be neutral. So I have K2SO4, and that's again going to be aqueous. So this time I'm going to put the information at the bottom just because I didn't give myself enough room at the top. I have 13.0 milliliters. Actually, even taking a look here, let's do this part first. I know that this is 4.0 moles of H2SO4 for every 1 liter of H2SO4. I have liters here. I need to convert this to liters, so I divide by 1,000. 0.0130 liters of H2SO4. So I can put that right in here instead. And then this one's 4.0. I'll do the whole thing. Moles over 1 liter. Box over. And then I have my KOH. Again, I have the same volume, so 0.0130 liters. And my concentration's my unknown, so X moles over 1 liter. So I always start with the one that I have the most information about, and that will be my, oh, actually, wait, first, I need to balance this. This isn't balanced, right? So I know I have an H from here. I have an OH from here. So we've got to kind of figure out where everything comes from. I'm going to kind of play around with my K's here. I have 1 potassium here, 2 there. So I would need to put a coefficient of 2 in front of here in order to make those two equal. Now I have 2 OHs here, 2 H's there, so I would put a 2 in front of there, and now everything is balanced. All right, cool. So now I can go through and figure out, okay, my acid, I have the most information about that. I'm going to start with this one, and I'm going to start with a number that I don't have anything as a denominator for. So I will do 0.0130 liters of H2SO4 over 1. That 1 is just a placeholder. And then I have, I multiply 4.0 moles of H2SO4 for every 1 liter of H2SO4 and cancel those out. And now I need to get from moles of H2SO4 to moles of KOH. So I can use my balanced chemical equation to help me. I know that there's only a 1 right here, so that's 1 mole of H2SO4, but I have 2 moles of KOH. So I'm going to cancel out the moles of H2SO4. Now I'm left with just moles of KOH, and I need moles over liters, so my next one, I'm just going to put the volume down here, 0.0130 liters of KOH, and I'm going to put the 1 on the top as a placeholder. So if I think about how to put this into my calculator, I can kind of get rid of some numbers, right? So like, I don't need to worry about the ones. The 0.0130 liters is on the top and the bottom, so maybe I cancel out those numbers too. So when I think about this, I only have 4 times 2, which should give me 8. So 8.0 molar KOH. And let's make sense of this. We had the same volume for both, so it should have made sense that they were going to be the same concentration for both. But because our balanced chemical equation showed us that we had twice as much KOH than we did H2SO4, we put that in as a factor over here, and that's how we got twice the concentration of KOH as we did the concentration of the H2SO4. I went through this pretty quickly. I know this is a lot, and an introduction to what we have for stoichiometry. But let me know what questions we have. And again, hopefully you've gotten a chance to like really pay attention to this as opposed to just blindly writing things down, because that may not be as helpful. All right, I will see you in class. Take care. Bye.